with our topic of carbon compounds. So I hope in the last session you have understood all the topics which I have covered. So let's continue with our topic. So let's start now with our session. So students, today we are going to deal with the topic of chemical properties of carbon compounds. Now, in the previous session, we learned about the properties of carbon, then carbon compounds, then causes of versatility of carbon, then we have seen about the hydrocarbons, then how to write the common names and the IUPAC names. Then now today in this session, we will study about the chemical properties of carbon compounds. So dealing with the chemical properties, what do you mean by the chemical properties? Okay, so here the characters of particular substances observed in a chemical reaction. For example, what happens when reactants are heated? What happens when it undergoes combustion reaction? So different types of reactions are there where we study about what happens when these reactants go under these reactions and what are the products which are formed. So here we will study about the chemical properties of carbon compounds. So first we will study about the combustion reaction. Now starting with this combustion reaction, we should know that what do you mean by the combustion reaction. Now here the process of burning of carbon and carbon compounds in excess of oxygen to give heat and light, they are known as the combustion reaction. Now carbon in the form of various allotropes on ignition. Ignition means burning. Okay. So in presence of oxygen, they undergoes combustion. And after combustion, what happens? It emits heat and light and forms carbon dioxide. If hydrocarbons are there, then what will happen? It will go combustion reaction, and in this process, what will happen? With carbon dioxide, heat and light, it will also gives water molecule. Okay, so here you can see carbon compounds burn in oxygen to form water, carbon dioxide, heat and light. Now see here, example is given. Carbon reacts with O2. Okay, when they are heated, then we get carbon dioxide and heat and light is evolved. Then comes the methane molecule. When methane molecule burns in presence of oxygen, we will get water molecule, carbon dioxide, heat and light is evolved. Then comes the ethyl alcohol. Okay, now ethyl, why? Because there are two carbons and OH group is present. So that's why we are telling the name it as ethyl alcohol. Okay, so yesterday only we have seen how to write the common names of the compounds. So this is ethyl alcohol. So, or you can call it as an ethanol. So when ethyl alcohol burns in presence of oxygen, it gives water molecule, carbon dioxide, heat and light. That means in a combustion reaction, if hydrocarbon is present, hydrocarbon means the compound containing hydrogen and carbon. For example, the methane and the ethanol, they containing both the carbon and the hydrogen. If they are present and if they burn, they are burned in presence of oxygen, then what will happen? We will get water molecule, then carbon dioxide, heat and light. Okay, but if hydrocarbons are not present, okay, only carbon is present, when carbon is only burned in presence of oxygen, then what we will get? We will get carbon dioxide, heat and light will be evolved. Here water molecule we will not get. Okay, so just understand the difference between these reactions. Three reactions I have written there, and in between these three reactions, just understand the difference. If hydrocarbons are there, that is methane and ethanol containing hydrogen and carbon, water molecule will be the product, water molecule, carbon dioxide, heat and light. But when hydrocarbon will not be present, when carbon is burned in presence of oxygen, then you will get only the carbon dioxide, heat and light will be evolved there. So next, then comes to the next slide. Okay, so this was for the combustion reaction. Then comes the oxidation. Now carbon compounds start burning by combining easily with oxygen in the air when ignited in air. So in this process of combustion, all the chemical bonds in the molecule of the carbon compounds break and CO2 and H2 are formed as the product. So in other words, the carbon compounds is completely oxidized during the combustion. So here chemical compounds can also be used as a source of oxygen here. So substances that can give oxygen to other substances are called as oxidants or oxidizing agent. Likewise, potassium permanganate or potassium dichromate. These are the oxidizing agents, and these affects on certain functional groups. Now here you can see the example. Now oxidation means, if oxidation is written, oxy means addition of oxygen. Simply, okay. Whenever oxidation will be given, there you can say that it is the addition of oxygen. So here you can see that whenever oxidation, addition of oxygen, so carbon compounds like alcohols, they are oxidized to carboxylic acid. Now see the example. Alcohols are oxidized to carboxylic acid. Ethanol in presence of alkaline KMnO4 and heat, or in presence of acidic potassium dichromate and heat. Then what they will give? Their addition of oxygen takes place. Now here you can see in this example, ethanol containing how many number of hydrogen atoms? See, 2 carbons are there, hydrogen 5 plus 1 hydrogen from that OH group. That means 6 hydrogen atoms are present. Now what will happen in oxidation? Addition of oxygen will take place and removal of hydrogen will take place. So always remember, in oxidation process, always addition of oxygen will take place, as the name itself tells that oxidation, and here removal of hydrogen will take place. Now 6 hydrogens are there in ethanol, if you will count it, okay, combining with that OH group hydrogen also, okay. So if 6 hydrogens are there, now after the reaction, just count the number of hydrogen there in ethanoic acid, you will get that from CH3, that 3 hydrogen from CH3 and COOH, that is 1 hydrogen from that. That means here 4 hydrogens are present, and in the reactant number of hydrogen were 6, and in the product the number of hydrogens are 4. So that means here removal of hydrogen took place, and plus here in the reactant side, in the ethanol, the number of oxygen is 1, whereas in the ethanoic acid the number of oxygen is 2. So here that means addition of oxygen takes place and the removal of hydrogen has been taken place. So here alkaline KMnO4 and acidic potassium dichromate, they are the oxidizing agent. Now what do you mean by the oxidizing agent? The agents that itself does not undergo oxidation, but it oxidizes the other compound which is present, okay. So agents means, likewise you know that the agents are those which do our work, okay. If certain, you hire certain agents, okay. Likewise, while making the reservation of a train, if you hire any agent, what he will do, he will not take the ticket of himself, he will take the ticket of yours, okay. He will just go on do the reservation of your ticket. So that's why the agent means the one who does not itself undergo any reaction, but it increases, speed up, or make the reaction of other compound, okay. So here oxidizing agent means it does not oxidizes itself, but it oxidizes the other compound which is present, okay. So here always remember that whenever in the reactant, okay, or whenever in presence of alkaline KMnO4 or acidic K2Cr2O7, we do any reaction, there always oxidation will happen, because these two are the oxidizing agents. So here in short, alcohols are oxidized to carboxylic acid. Here what will happen? Ethanol will get oxidized to ethanoic acid. That means here removal of hydrogen takes place and addition of oxygen takes place. And ethanoic acid and one more side product will be formed, that is water molecule. Okay, which is not written here, but one more side product, that is water molecule, will be formed here. So here oxidation is the process where oxidation, that means addition of oxygen, takes place and the removal of hydrogen takes place. Then comes the addition reaction. Now in addition reaction, what happens? When a compound combines with another compound to form a product that contain all the atoms in both the reactants, that is known as the addition reaction. So if unsaturated compounds, they contain some multiple bond as their functional group, so they undergo addition reaction to form a saturated compound as the product. So the addition reaction of an unsaturated compound with iodine or bromine takes place instantaneously at the room temperature. So here you can say that addition reaction means what? Addition is just the opposite of the oxidation, you can say. Now, what happens in oxidation? We have seen that their removal of hydrogen takes place. But in addition reaction, here we are adding the hydrogen. As you can see, unsaturated hydrocarbon. Now, what do you mean by the unsaturated hydrocarbon? Unsaturated means having double bond or triple bond. We have seen earlier, in the earlier sessions we have seen. So then this undergoes addition reaction. Okay, this all undergoes the addition reaction with hydrogen in the presence of nickel or palladium as catalyst to form the saturated hydrocarbons. Okay, so here ethene undergoes addition reaction with hydrogen to form ethane in the presence of nickel or palladium as catalyst. Now catalyst. Catalyst means what? A substance that causes or speeds up a chemical reaction without itself being changed. Okay, so here catalyst does not go itself any change. It does not undergo any change in it itself, but it speeds up the reaction or make the changes in the reactant. Okay, so now first of all, addition means we are adding. Okay, if unsaturated hydrocarbon is there, then what we will do? Now how this double bond come between the two carbon atoms? Because of the deficiency of hydrogen. Okay, if suppose CH3 bond CH3 is there, so there is a single bond and both the carbons are satisfied by the 4 bonds. But if one hydrogen are removed from them, then what will happen? 2 bonds will be formed between the carbon and carbon. Why? Because carbon is having the tendency to form 4 bonds. So here unsaturated hydrocarbons, they undergo addition with hydrogen. Now if double bond is there, in that we are adding hydrogen again, then what will happen? That double bond will be removed because now carbon can form bond with hydrogen. So likewise the same reaction takes place here. Here you can see ethene molecule is present, C2H4. Okay, below diagrammatic form is also written there, C2H4 is given, and when we add hydrogen to it in presence of nickel or palladium as a catalyst. Now, whenever in the reaction nickel or palladium is present, that means addition of hydrogen will take place. Okay. Now then what will happen? You will get C2H6. That means that double bond will be removed and 2 hydrogen will be added to that respective carbon atoms. Okay. Now here you will get the product as ethene. You will get the ethane molecule. So from ethene was an unsaturated hydrocarbon. From ethene you will get saturated hydrocarbon, that is ethane molecule. Okay. Now always remember, suppose in the exam you are writing the addition reaction, but you wrote wrong catalyst. In presence of nickel or palladium, if you are showing the addition reaction, you have written alkaline KMnO4, then that will be wrong, because alkaline KMnO4 and acidic potassium dichromate always gives the oxidation reaction. And in the addition reaction, here nickel and palladium, they always gives the addition reaction. So don't just miss this catalyst. Okay, these catalysts are also very important. In presence of these catalysts only, these reactions are taking place. Okay, so then comes the next reaction, substitution reaction. Now substitution means replacement. Okay, Replacement means what if hydrogen is present and in place of hydrogen we are putting something, another functional group. It may be OH, it may be Cl, okay, it may be amine group. So whatever functional group we are replacing it, so that is known as the substitution reaction. So now here saturated hydrocarbons undergo substitution reaction. Now in the addition reaction, what we have seen that unsaturated hydrocarbons, they undergo addition reaction, okay, unsaturated, where double bonds were present. Whereas in substitution reaction, what we are doing here, we are using the saturated hydrocarbons. That means suppose methane molecule is present, CH4. So carbon is bonded to 4 hydrogen atoms. Okay. So carbon is bonded to 4 hydrogen atoms with a single bond. Now what will happen? We are substituting one hydrogen atom with a halogen atom. You can use chlorine, you can use bromine, you can use iodine, you can use fluorine. Now here, any of the halogen you can use. So if we are taking the example of a chlorine molecule, then what will happen? CH4, carbon forms 4 bond with hydrogen. Now one hydrogen from this methane molecule will be removed and it will be replaced by chlorine atom. So here Cl2 is there. So one chlorine will be attached to the methane molecule and that hydrogen which was replaced, okay, the removed hydrogen will be form bond with Cl, remaining Cl atom which was remained after the reaction of that Cl2. So that will form hydrochloric acid, that is HCl, that will form. So here CH3Cl, that is chloromethane, will form. Then again it undergoes substitution reaction. Then what will happen? Now how many number of hydrogens are present? 3 hydrogens are present. Now one hydrogen will be removed by the chlorine molecule, and what will happen? Again, after substituting, after the replacement of one hydrogen, now the number of chlorine will be 2, okay, in the methane molecule. So here CH2Cl2, that is here 2 hydrogens are removed and 2 Cl has been attached to it by replacing the hydrogen. Now then you can see CH2Cl2 again get attacked by the Cl2. Then what will happen? Another hydrogen will be replaced by the Cl2. Okay, then CHCl3 will be formed. Then again CHCl3, one hydrogen is remaining. Now again it is attacked by the Cl2. Then what will happen? Carbon tetrachloride will be formed. So here we will get carbon tetrachloride. That's in this process we are just replacing all the hydrogen one by one. So that means whenever the replacement reaction takes place, that is by removing the hydrogen and adding the functional group. Okay, so the saturated hydrocarbons, as CH4 is a saturated hydrocarbon. So what will happen? This reaction happens in saturated hydrocarbons because in double bond it is not that much possible. Okay, if only 2 carbons are there and double bonds will be there, it is possible in some cases, not in all cases. Okay, so here saturated hydrocarbons are present. So these saturated hydrocarbons, they undergo the replacement reaction with the halogen to form a product. Here the product is to form a substituted product, which is known as, here example I have given of methane. Methane undergoes substitution reaction with chlorine in presence of sunlight, okay, to form a substituted product, carbon tetrachloride. So likewise it goes on removing one by one hydrogen, and then it removes all the hydrogen and it itself get attached to that carbon atom. Okay, now here, so I hope you have understood about the 4 reactions. So if you want me to recall, I can recall once because these are important. Now see here, chemical properties of carbon compounds. First is the combustion. In combustion process, what will happen? If carbon is there, it burns in presence of oxygen, then it will give carbon dioxide, heat and light. Then if hydrocarbon will be present, for example, methane and ethanol, then when it burns in presence of oxygen, it will give water molecule, carbon dioxide, heat and light. Then second reaction is the oxidation reaction. The name itself tells us oxidation means addition of oxygen here. Okay, so this addition of oxygen takes place in presence of alkaline KMnO4 or acidic K2Cr2O7. Alkaline KMnO4 means potassium permanganate, and acidic K2Cr2O7 means potassium dichromate. So whenever these catalysts are present, so here what will happen? Oxidation will take place. That means ethanol will get converted into the ethanoic acid. Okay, so here oxidation takes place. That means addition of oxygen takes place and removal of hydrogen takes place. Then addition reaction, here unsaturated hydrocarbons are present which undergoes addition reaction. Okay, double bonds are present, so they are removed by adding hydrogen to it, and what will happen? We will get a simple alkane molecule. So likewise, that means a saturated hydrocarbon we will get. So this is the conversion from an unsaturated hydrocarbon to the saturated hydrocarbon. So here in presence of nickel or palladium. Okay, the catalysts which are used are in addition reaction, nickel and palladium. If nickel and palladium is there, then there will be addition of hydrogen. Okay, so then comes the substitution reaction, where what will happen in presence of sunlight? Here saturated hydrocarbon we are using as a reactant, whereas in addition reaction we used unsaturated hydrocarbon. But in substituted reaction, here we are using the saturated hydrocarbons. That means hydrocarbons containing single bond. So they undergoes replacement reaction with the functional group. So here we have taken the example substitution reaction with halogen to form a substituted product. Example is methane. When undergoes substitution reaction with chlorine molecule, what will happen? It gives the substituted product, which is carbon tetrachloride. Okay, and this reaction takes place in presence of sunlight. Okay. Then comes the few important carbon compounds. Now we will take two examples of carbon compounds, ethanol and ethanoic acid. So first we will see about the ethanol. Now ethanol, the formula for the ethanol, I have written here C2H5OH. Now ethyl alcohol, we can call it as ethyl alcohol also or ethanol also. Okay, yesterday only I told you how to write the common names and IUPAC names. Two carbons are there, so it we are using as a root word. Okay, and as it is a molecule containing it is a type of compound of alkane. So here we are writing it as ethane, and E is replaced by, as OH is attached to it, so OL. So that's why ethanol. Okay, so first we will see the properties. Ethanol is a colorless liquid with a pleasant smell and burning taste. Now it is having a very colorless liquid is there, color is not present. Then having a pleasant smell means it is not having a pungent smell and all. So and is having a burning taste, like it is having a burning taste. If suppose you put it on your tongue, then you will have the sensation of burning. Okay, so here it is soluble in water, it gets miscible in water. If water and ethanol mix together, you will not be able to identify whether water is there or not. So it is soluble in water. Okay, then ethanol reacts with sodium to form sodium ethoxide and hydrogen. Now one reaction happens with ethanol. Many reactions happens actually. This is one of them, where ethanol, they reacts with sodium. Now you can see here ethanol reacts with sodium, then it will give sodium ethoxide. Now you can see that C2H5OH. Now in OH, that hydrogen is removed, and in place of that hydrogen of that OH group, hydrogen is removed, and in place of that hydrogen, Na is attached to it. Okay, so here this is also one kind of replacement reaction where Na is attached to that O. So now you will get the sodium ethoxide. Okay, this is sodium ethoxide, and two hydrogen gas is evolved. Okay, so here H2 is evolved. So likewise, ethanol reacts with sodium to form sodium ethoxide, and hydrogen is evolved here. So you can see then we have balanced the reaction. Ethanol with Na, that H is replaced by Na, and we get sodium ethoxide, hydrogen is evolved. Then comes the ethanol reacts with hot concentrated H2SO4. Now H2SO4, concentrated H2SO4 acts as a dehydrating agent. Now what do you mean by the dehydrating agent? Dehydrating agent means the compound which the catalyst which removes the water molecule from the reactant, that is known as dehydrating agent. Okay, which removes the water. Now here ethanol reacts with hot concentrated H2SO4 to form ethene and water. So here concentrated H2SO4 acts as a dehydrating agent and it removes the water from ethanol. You can see the example here in ethanol C2H5OH in presence of concentrated H2SO4. Now whenever the reaction takes place in presence of concentrated H2SO4, it will remove water molecule. Okay, so here you can see, first we will count the number of hydrogen, carbon and oxygen atom in the ethanol. Number of carbon is 2, number of hydrogen is 6. This H5 plus 1 from that OH group. Okay, hydrogen. So here number of hydrogen is 6 and 1 oxygen is present. So what will happen? From this 6 hydrogen atom, 2 hydrogen atom will be removed and 1 oxygen atom will be removed. So that 2 hydrogen, that is H2, and 1 oxygen, that is O, that is H2O, water molecule will be removed, and then we will get, what we will get? We will get the product C2H4. And what we called it as C2H4? It is an ethene. It is an ethene molecule having double bond between carbon-carbon. Okay, so here ethanol undergoes dehydration in presence of concentrated H2SO4 and it will give ethene and water molecule. So two reactions we have seen, one with the sodium and another with the in presence of H2SO4. Then comes the uses of ethanol. Now ethanol is used for making alcoholic drinks. Then it is used as an solvent. Then it is used for making medicines like cups, syrups and tonics, etc. Okay, so in different types of cups, syrups and tonics, they use ethanol there. Okay. Now then comes the ethanoic acid, that is CH3COOH. It is also known as the acetic acid. Now the properties of ethanoic acid. Now ethanoic acid, okay. Now you might have seen that most of the acid, they are having a pungent smell. Okay, they are colorless. Acids are mostly colorless only with a pungent smell and sour taste. Okay, they don't have a good taste obviously, and don't taste it. Otherwise your tongue will be burned. So acid, don't taste it. So ethanoic acid is a colorless liquid with a pungent smell and sour to taste. So it is soluble in water. It can be miscible in water, and when you mix it with water, it becomes little bit dilute. Okay, then a solution of 5% to 8% ethanoic acid in water is called as vinegar. Now you might have seen in the shops we get vinegar there. So in that vinegar, 5 to 8% ethanoic acid is present in water. Now then comes the esterification. Now what do you mean by the esterification? As the name itself, esterification, that means here formation of ester maybe takes place. Esterification, name itself states. Okay, formation of ester takes place. Now this esterification reaction can only happen with the ethanoic acid here. Okay, with the carboxylic acid, whatever the carboxylic acids and alcohols are present, when they get reacted with each other, they form ester. Okay, so here you can say, if they in the exam they ask what you mean by the esterification, you can write the reaction between the carboxylic acid and alcohol to form an ester is called an esterification. Okay, so here ethanoic acid, they reacts with ethanol. You can see CH3COOH and reacts with C2H5OH in presence of concentrated H2SO4. Then what it will give? It will give, now here you can see that the HCO in the reactant side. Okay, two reactants are present here. One is the ethanoic acid and second one is the ethanol. Now from the ethanoic acid, what they have done, they have just removed one hydrogen which is present in the carboxylic group, one hydrogen from that side, and it is replaced by the C2H5 of ethanol. Now this C2H5 get attached to that carboxylic group, and what will happen then? Formation of ester takes place, and that hydrogen which is removed from the ethanoic acid get mixed with that OH group from the ethanol, and they will form the water molecule. So here in presence of H2SO4, what will happen? Now as we know that H2SO4 is a dehydrating agent, so here it will remove water molecule as H2SO4 is present, so it will remove water molecule. So with water molecule, what will happen? It will also give us ester. Now the name of this ester is ethyl ethanoate. Okay, because now why ethyl ethanoate? Because first of all, ethyl molecule, ethyl group is present. After that, COO group, ethyl group is present, and here ethyl ethanoate as ester is there. So OATE. Okay, this is the keyword for that ester. So here ethyl ethanoate. Okay. Then the reaction between the carboxylic acid and alcohol to form an ester is called as esterification. So whenever it is asked what you mean by the esterification, the reaction between the carboxylic acid and alcohol to form an ester is called as esterification. Then comes the saponification. Now esterification, saponification, okay, these reactions we can see mostly in the ethanoic acid only. Now what happened in the saponification? When an ester reacts with sodium hydroxide, okay, whenever there any of the ester when reacts with sodium hydroxide or NaOH we can call. So then what will happen? The sodium salt of carboxylic acid and the parent alcohol are formed. Now here what? Now in the esterification reaction, what we have used? Here carboxylic acid and alcohol has been used and we get the ester. Whereas in saponification what we are using? We are using ester plus NaOH. Then what we will get? We will get the parent alcohol group and also sodium acetate. Now here you can see CH3COO, C2H5 and NaOH. Now here C2H5 get replaced with the Na of NaOH. Okay. So then so C2H5 is replaced by Na, so we will get CH3COO Na. Then that C2H5 again gets reacted with OH group. So what we will get? We will get ethanol. So here this type of reaction takes place in the saponification. So saponification, what do you mean by the saponification? When an ester they react with sodium hydroxide solution, the sodium salt of carboxylic acid and the parent alcohol are formed. Okay, so sodium salt of carboxylic acid is formed and the parent alcohol is formed, and this process is known as the saponification. Then comes the ethanoic acid when reacts with bases. Now as we know that NaOH is a base. Likewise we know that HCl is an acid, H2SO4 is also an acid. But NaOH is a base, NH4OH is also a base. Okay, so here when ethanoic acid reacts with base, so here we have taken the example of base of NaOH, that is sodium hydroxide. So here ethanoic acid when reacts with NaOH, we will get it forms salt and water. Okay, so same way it is forming the sodium acetate only. Here again that H of COOH group in the ethanoic acid is replaced by the Na, and what we will get? We will get the sodium acetate and water molecule will be released as a side product. So here H from the carboxylic acid and OH from the NaOH, they combine to form water molecule and the remaining forms is sodium acetate. So in both the reactions, okay, with ethyl ethanoate and with ethanoic acid, we are getting the same product of sodium acetate. Okay, then again ethanoic acid they reacts with carbonates and hydrogen carbonates. Carbonates means that sodium carbonate example is given here. Hydrogen carbonates means here sodium bicarbonate example have been taken. So where ethanoic acid, okay, ethanoic acid reacts with sodium carbonate. Okay, now what happens here? Again CH3COOH molecule is there and Na2CO3. These two reactant molecules are there. Now what happens here? The H of COOH group is replaced by the sodium, and then we will get where the reactants, here the reactant ethanoic acid and carbonates. When they react, we will get sodium acetate. Same for the bicarbonates also. When ethanoic acid reacts with sodium bicarbonate, then what we will get? We will get sodium acetate. Water molecule as a side product and CO2. Okay. So here, this was all. Saponification. Saponification means an ester which reacts with sodium hydroxide solution. The sodium salt of the carboxylic acid and the parent alcohol is formed. This reaction is known as the saponification. In all the reaction, first we have reacted the ethyl ethanoate with sodium hydroxide. We get sodium acetate. Then we have reacted the ethanoic acid with sodium hydroxide. Again, we get sodium acetate. Then ethanoic acid with carbonates, we get sodium acetate. And ethanoic acid with sodium bicarbonate, we get sodium acetate. That means in all the cases, we are getting the sodium salt of carboxylic acid. So whenever we are getting this sodium salt of carboxylic acid, that means this is the process called the saponification. Then comes the physical properties. Now, ethanoic acid and ethanol. Now, as we know that acid is having a pungent smell and ethanol is having a pleasant smell. The melting point of ethanoic acid is much higher as compared to that of ethanol, that is 290 Kelvin. So here, melting point of ethanol is 156 K. So here the boiling point of ethanoic acid is also more than that of the ethanol. That is 391 K, and here ethanol is having the 351 K. So here in all the cases, ethanoic acid is having the higher melting point and higher boiling point as compared to that of the ethanol. Okay, so again we will revise in short the compounds. Ethanol. So ethanol is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. Then when ethanol, it reacts with sodium, it will give sodium ethoxide and hydrogen gas will be removed. Then ethanol in presence of concentrated H2SO4. H2SO4 is a dehydrating agent. That means it removes the water molecule, and here we will get ethene and water molecule. Okay, so ethanol undergoes these two reactions, one with sodium and another with H2SO4. Okay, in both the cases, what product we get? In one, when it reacts with sodium, we will get sodium ethoxide, and when it reacts in presence of H2SO4, that is concentrated H2SO4, as a dehydrating agent, it will remove the hydrogen and we will get ethene. Then comes the uses. Ethanol is used for making alcoholic drinks. It is used as solvent. It is used for making medicines like cough syrups and tonics. Then comes the ethanoic acid. Formula is CH3COOH. That is also known as acetic acid. Properties are, it is a colorless liquid, pungent smell and sour to taste. It is soluble in water. Both ethanol and ethanoic acid, they are soluble in water. In market, whatever we are getting vinegar, that contains 5 to 8% of the ethanoic acid in water. Process of esterification. Now, what do you mean by the esterification? The reaction between the carboxylic acid and alcohol to form an ester is called esterification. Here, carboxylic acid, which carboxylic acid I took here? Ethanoic acid. When it reacts with ethanol, any of the carboxylic acid or alcohol, when they combine, we get ester only. Okay. So here removal of water molecule takes place, and what will happen? C2H5 replaces the hydrogen from the COOH group, and we will get the ester. Which ester? Ester ethyl ethanoate. Then comes the saponification. When ester reacts with sodium hydroxide solution, the sodium salt of carboxylic acid we are getting, and parent alcohol is formed as a side product. So here this process is known as the saponification. Okay, so here ethyl ethanoate reacts with sodium hydroxide. We get sodium salt of carboxylic acid or sodium acetate, and ethanol. Then when ethanoic acid reacts with NaOH, they form salt, that is sodium acetate and water. Then ethanoic acid when reacts with carbonates and hydrogen carbonates, that is sodium carbonate and sodium bicarbonate, it forms salt, water and carbon dioxide. Salt is sodium acetate only. Okay, so yes, CH3COOH and Na2CO3. Na replaces the hydrogen and we get sodium acetate. Below also same way with sodium bicarbonates, ethanoic acid, they reacts with sodium bicarbonate, then we will get CH3COONA, that is sodium acetate, water molecule, and CO2 is the side product. So likewise saponification and esterification. Then we have seen about the physical properties: pungent smell, pleasant smell. Pungent smell is of ethanoic acid. Ethanol is having the pleasant smell. Melting point and boiling point of ethanoic acid is more as compared to ethanol. Then comes the chemical properties. So ethanoic acid and sodium bicarbonate, it gives CO2 gas, as we have already seen. But in ethanol, no CO2 gas is produced. Okay. So yeah, this is the difference in their chemical properties or in the chemical reaction, that in ethanoic acid CO2 gases evolve, whereas in ethanol no CO2 gases evolve. Then in ethanoic acid, on addition of alkaline KMnO4, that is potassium permanganate, the color does not disappear. Whereas on addition of alkaline KMnO4, the color disappears in the ethanol. So these two differences are there between the chemical properties of the ethanoic acid and ethanol. So likewise, I hope you have understood. So we will see questions now. Now tell me, what do you mean by the process of combustion? Anyone can answer? Process of combustion. Combustion is...
yourself and answer. Unmute yourself and answer. You're raising.
Unmute yourself and answer.
Unmute yourself.
Hello, ma'am.
Yes.
Ma'am, when carbon compounds burn in oxygen to form water, carbon dioxide, heat and light.
We get carbon dioxide, heat and light. Yeah.
Yes,
right.
ma'am.
Good. Then comes, what do you mean by the esterification? Yes. Unmute yourself.
Yes, miss.
Yes.
The reaction between carbolic acid and alcohol to form ester is called the method of esterification.
Yes, the reaction between the carboxylic acid and alcohol to form an ester is known as esterification. Very good. Then comes, what do you mean by the saponification?
Ma'am,
Yes.
when an ester reacts with sodium hydroxide solution, the sodium salt of the carboxylic acid and the parent alcohol are formed. This reaction is called saponification.
Yes, very good. This process is the saponification. Good. Now tell me, if ethanol is oxidized with alkaline potassium permanganate, then what product we will get? Ethanol is oxidized. That means we are adding oxygen in it and removing the hydrogen. So if ethanol is oxidized with alkaline potassium permanganate, then what product we will get? Yes, unmute yourself and answer.
Only 2 students are raising their hands. Unmute yourself.
Yes, answer. Unmute yourself and answer.
मम्मी कॉपी इनवाइट लाइक केला.
Yes, who is there? Answer.
Pooja, you're answering. Sakshi.
Just wait, ma'am.
Okay, so we will get ethanoic acid. Okay, because here the addition of oxygen takes place and removal of hydrogen takes place. So I hope you have understood the topic. Thank you for giving me this opportunity. And thank you all the teachers and my dear student, and thank you BMC Edu.
Thank you, ma'am.
Thank you, ma'am.
Very much. Thank you, students. Tomorrow again we'll be meeting at 8 o'clock. Till then, you can practice the topics which have been taught today. We had 4 lectures. So all the 4 lectures, whatever topics were taught to you, get that. And tomorrow you can be ready for the doubts.